In this section, we are going to look at the quotient rule. So if you recall from last time, we talked about the product rule, which gave us a way of finding the derivative for two functions being multiplied together. Now we're going to do the same thing, except we're going to be looking at functions that are divided. So in this case, let's take two functions, f and g, such that capital F is f divided by g. Then we can find the derivative by doing the following. First, we can treat this as just a product of functions. So we're going to multiply both sides by g of x. And if we do that, we can use the product rule, which says it's the derivative of capital F times g plus capital F times derivative of g. And that'll be f prime. Okay. Now, between these two steps, we're going to do a little bit of algebraic manipulation, which means I'm going to move capital F times g prime to the other side, so I'm going to subtract that off. And then I'm going to divide out by g of x. And so now we have an expression for capital F prime. The only problem is I still have capital F in there, and I want to get this in terms of the two functions that we're dividing. So I'm going to substitute. I'm going to take f over g, which is our capital F, and I'm just going to plug that in. And then what we notice is, in order to simplify this, I'm going to need a common denominator. So I'll multiply by g of x to get f prime times g minus f times g prime, and then that extra g goes into the denominator. This is our partial with respect to x, or another way to think of it is the partial with respect to x of f divided by g is going to be f prime g minus fg prime all over g squared. Okay. This is our quotient rule. Okay. And again, just like our product rule, this is one that you're going to need to know for some of the applications that we're going to look at, as well as some things later on the final. Okay. So let's look at a couple examples of our quotient rule. Okay. In this first one, we've got f of x, which is 4x squared plus 3 over x squared minus 1. Now, applying our quotient rule, it basically says I'm going to take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay. Again, I'm going to use our prime notation to denote this. So the derivative of the top times our bottom minus the top times the derivative of the bottom, all divided by the bottom squared. Okay. Expressions like these are things we tried to simplify in our prerequisite material, and this is where that material is going to come back to play, mostly when we're dealing with our quotient rules. Okay. To simplify, we need to take our derivatives. So the 4x squared, we can use our power property. Again, 3 goes to 0. The second term, there's no prime, so I'm not taking a derivative. Same thing with the 4x squared plus 3 for the second term. And here again, I'm taking derivative, which again is going to be a power rule. From there, I can now simplify the numerator. Okay. So in the numerator, I can multiply out. We'll get an 8x cubed minus an 8x. Over here, minus an 8x cubed minus a 6x. Don't forget to distribute your signs. And then we can simplify. So notice the 8x cubes go away. We're left with a negative 14x over x squared minus 1 squared. Let's look at our next example. So in our next example, f of x looks like 3x plus the cubed root of x over 2x minus 5. and we want to take the derivative of this. So again, we're going to start by labeling which pieces we're derivating at a time. Okay? So again, we'll do the top, and if it's okay with you, I'm going to write this as x to the 1/3 times the bottom minus the top times the derivative of the bottom, all over bottom squared. Okay. So here, just like before, we'll take the derivatives. For the top piece, derivative of the top, we're going to get a 3 plus a 1/3 x to the negative 2/3. That's going to be multiplied by the 2x minus 5. And then for the second piece, we're subtracting. 3x plus the x to the 1/3 is not going to change, but then we're going to multiply by the derivative of 2x minus 5. Again, all of this is over the denominator squared. Again, at this point, it's a matter of simplifying. So again, we're going to distribute on the top. So we'll get a 6x plus a 2/3 x to the 1/3 minus 15 minus 5/3 x to the negative 2/3 minus, distributing here, we'll get a 6x minus a 2x to the 1/3. Again, don't forget to distribute. All of this over our denominator squared. Combining like terms, we can see that the 6x terms will go away. We'll get a negative 15. The x to the 1/3 terms will accumulate. Excuse me. And then we have our 1x to the negative 2/3. Now for this one, we're not quite done. First thing to notice is we do have some complex fractions in there, so you do want to simplify that down. But also, if you remember from the start of the problem, we had some roots, but we didn't have any negative roots. So those we want to get rid of as well. Okay. So to do this, we are going to first think of this in terms of getting a common denominator on the top. So because of that negative 2/3 power, our common denominator is going to be 3x to the 2/3. So we'll have a negative 45x to the 2/3 minus, we'll need to multiply by an x to the 2/3 there. That 3x to the 2/3 is in the denominator now, all over our 2x minus 5 squared. Okay. So in that step, from here to here, all we did was get a common denominator on the top. Once we've done that, now we can combine the denominators in the complex fraction, and we can see minus 45x to the 2/3 minus 4x minus 5 over 3x to the 2/3, 2x minus 5 squared is going to be our f prime of x. And there's our quotient rule.